So you can impress your friends with the name of this next section. We're going to be solving nonlinear systems of equations. Ooh, sounds pretty meaty. Tweet about it, and get some people to be in awe of your intellectual prowess. So the idea, though, is really not much different than what we were doing with solving systems of linear equations. We're trying to find where two lines or two graphs cross each other. So let's look at these first pair. Problem number 16. You've got this first figure. What do you think I'm going to get when I graph x squared plus y squared equals 16? Anyone? Circle. Centered at 0, 0. What would the radius be? Someone x. Radius would be 4. All right, so circle radius 4. And this one is just a line, right? So where do those two figures cross each other, if at all? Remember, they're not guaranteed to cross each other. There's a couple ways you can solve this. One is substitution, one's addition. So in this case, I think I'd go for substitution because we can't add a y squared and a y and get things to cancel each other out. It's just not going to happen. So the easiest thing to do would be to move the x to the side and get y equals x minus 4. If y equals x minus 4, I can take that and plug it in to the top equation. So I get x squared plus x minus 4 squared equals 16. Now it's really cool if you can square that out in your head. If you can't, that's fine. Multiply x minus 4 times x minus 4. But no matter what you do, please don't end up with x squared plus 16. There's a little bit more that goes into those parentheses than just that. So if you square this out, and this is a good skill to have, what I do is I square this term, and I square this term. Negative 4 squared is 16. And then I borrow this 2, because the middle term is 2 times this times this. So let's do the number part first. 2 times negative 4 is negative 8x. So negative 8x. That last term is always going to be a plus. Now you can FOIL it out, collect like terms, etc. That's great. Moving forward from here, at this point in your math career, I'd suggest you be able to start squaring these things out in your head. But let's continue. There's like terms on the left-hand side. So that's 2x squared minus 8x plus 16 equals 16. Okay. Now what? Should I pull out the quadratic formula? No. Subtract 16 from both sides. Good. We want to get 0 on one side. So if I subtract 16 from both sides, then I get 2x squared minus 8x equals 0. So let's bring that up here. Now do I need to pull out the quadratic formula? You could, but I hope you wouldn't, because you're going to be spending 10 minutes to solve this, and it really should take you less than 30 seconds. Factoring is your best friend here. How does this factor? It's not the difference of squares. GCF. What's the GCF on this one? 2x. If I factor out a 2x, it leaves behind an x and a minus 4. Amila, what are the two solutions that I get here? All right, so x equals 4, that's one of our solutions. Remember, x minus 4, one of these has to be 0. So either it's x minus 4, which means x equals 4. You don't have to show me that step. Or the other possibility is 2x equals 0. So that means if you divide by 2 on both sides, you get x equals 0. So there's two possibilities for x, 4 or 0. We need to figure out the corresponding possibilities for y. So if I set x equals 0, let's do that in this equation. You have your choice. I think it's easier to work with this equation. If I set x equal to 0, Yeah, something wrong here. Something wrong with my graph. All right, so if I set x equals 0, y minus 0 equals negative 4. If I set x equal 4, then y minus 4 equals negative 4. I get y equals 0. So the two pairs of points that I get would look like this. 0, 4, and 4 and 0. Uh, 0, 4. No, wait. 0 for x and be negative 4, right? There we go. 0, negative 4. That looks better. And then 4 and 0. So I think I just accidentally drew the wrong line when I graphed this thing. The line should look like this. Yeah, there's a typo in drawing the line. But you can see your solutions. There's two solutions. 4, 0 and 0, negative 4. Yay, nice. So not a lot different than our work with linear equations, other than it's a little more challenging at the end to finish finding our solutions. Remember, you're going to need both x and y coordinates for each of your points. When you're solving these kinds of things, a lot of things can happen. You don't necessarily just get one solution or two solutions, etc. The number of solutions can change depending on the geometry. So in our next problem, we've got a hyperbola and ellipse. How many solutions does it look like we have in this problem? Looks like there's two solutions. But if that hyperbola were a little different, I could easily have 4 solutions. Or I could have another one, maybe this one's the same, and have one like this. So I'd have 1, 2, 3 solutions. So you could have a lot of different possible solutions. It's just going to depend on the geometry. Is there any thoughts on problem 16 before I move on to the next one? Okay, so let's try problem number 18. The equations in 18 are x squared plus 9y squared equals 9. X squared plus 9y squared equals 9. What figure is that going to be if I graphed it? An ellipse. If you divide everything by 9, you get x squared over 9 plus y squared over 1 equals 1. Or better yet, x squared over 3 squared plus y squared over 1 squared equals 1. How do I know that's an ellipse and not a hyperbola? Because of the plus sign. All right. And, you know, maybe this will help you out a little bit. There's not too many things that you can add together to get 1. All right. There's just kind of a limited number of combinations. And the graph of an ellipse is kind of limited. It doesn't go on forever. But there's a lot of things that are different by 1. So the other part of problem number 18 is 9y squared minus x squared equals 9. Again, you could divide this by 1. Y squared over, divide it by 9. Y squared over 1 minus x squared over 9, which we'll write as 3 squared and 1 squared. So that's a hyperbola. There's a lot of things that are different by 1. And that's why you're getting this unlimited, unconstrained figure of a hyperbola. That one opens up and down. The ellipse opens, or doesn't open up and down. It's just a nice finite figure. All right, we don't need to rework those In fact, we're probably better off just dealing with these two equations as they are. Let's see if we can't use these two equations to solve it. So x squared plus 9y squared equals 9. I'm going to reorder this, the second equation. Any suggestions as to how I might want to rewrite that? Negative x squared plus, thank you. Why do we do that? Yes. This time we're going to use the addition method in order to eliminate this. So if I add these two equations together, look what happens to the x squared terms. Colin, what happens to the x squared terms? Yeah, they cancel. These disappear. What equation do I get when I add these together? 18y squared equals 18. Y squared equals 1. Now let's be careful here. What's the answer for y? Plus or minus 1. Good. You're going to take the square root on both sides. Make sure you get plus or minus. So plus or minus the square root of 1 is just plus or minus 1. Okay. So if we set y equal 1, say positive 1, back in one of the original equations, I would get x squared plus 9 times 1 squared equals 9. So a 1 here. So that's x squared plus 9 equals 9. X squared equals 0. What could x be then? What do you square to get 0? It's not a trick question, folks. What do you square to get 0? 0. Yeah. There's no plus or minus 0. That's okay. It's just 0. Now, did it matter that I put in a positive 1? Would the results have changed if I put in a negative 1 for y? Yeah, because when you square it and multiply by 9, you're still going to get 9, whether you start with 1 or negative 1. So either way you work it, if y is 1, if y is negative 1, x is 0. So you get two solutions, 0, 1, and 0, negative 1. Visually, you see that here. 0, 1, and 0, negative 1. Now, do you need the graph in order to solve? No. If I gave you the graph, if I said, hey, here's the graph, solve it, man, that'd be easy. How many solutions do you expect for problem number 32? 4. All right. And it's exactly these points. Kind of looks like a child's drawing of a satellite or something like that. Are we okay with problem number 18? So basically we use the addition method. Now, it's going to depend on the problem, what method you want to use, addition or substitution. It's up to you. Let's try problem 32. X squared plus y squared equals 13. X squared minus y squared equals 5. What method does this seem like it's just begging for? Addition method, absolutely. So let's go for it using the addition method. See if you can't find all 4 solutions without just looking at your handout. Obviously, what you need to do is you need to put them together to get all four of these solutions. You can't just write plus or minus 2 comma plus or minus 3. I would know what you mean, but I'd be a little uncomfortable with it. Yeah, yeah. Just realize it implies all four solutions. Good. Yeah, I'll talk about that in a second. Okay, when you take the square root, it's a plus or minus 2. Just like here, it's a plus or minus 3. All right, so let's add these two equations together. I mean, this one seems to just be begging for the addition method. When we do that, we get 2x squared equals 18. Divide both sides by 2. X squared equals 9. X equals plus or minus the square root of 9, or plus or minus 3. So let's set x equal to 3. If I set x equal to 3, I get 3 squared plus y squared equals 13. 3 squared is 9, so if I subtract 9 from both sides, I get y squared equals 4. So y is plus or minus 2. Now let's understand what this means. If x is 3, y could be 2, or y could be negative 2. So there's really two solutions that are implied here. Now, if we set x equal to negative 3, then again we're going to get two more solutions. If we square negative 3 carefully, you'll still get a positive 9. So y squared equals 13. So that's 9 plus y squared equals 13. Y squared equals 4. So y is plus or minus 2. And again, there's two solutions. Negative 3 goes with positive 2, and negative 3 goes with negative 2. Now, I know what you're meaning if you do something like this, if you write plus or minus 3, plus or minus 2, but I'm a little uncomfortable with that because not many people realize that there's four solutions. I shouldn't say not many, but not all people realize that this really implies four solutions and not just two. So I would ask that you write it all out when you finish like this. I mean, I understand that, but please just take a moment and write it all out. Here's your final answer. And we saw those 4 points of intersection on the handout right there. So works out pretty nice. With the types of problems you're facing, you can get 4 solutions, 3 solutions, 2 solutions, 1 solution, or no solutions. It just kind of depends on the geometry of the problem. It's hard for me to tell without looking at a graph or something, what to expect from a system of equations. You just can't tell. You just got to work it through. Any comments on problem 32? Let's try problem number 54. X squared plus 9y squared equals 1. And x squared minus 9y squared equals 3. Now, neither of these are in kind of that nice standard form that we were working with in section 13.2 and 13.3. But can you tell me what figures they would be if I were to graph them? What would they look like if I graphed either of these, or both of these? All right, good. An ellipse and hyperbola. Hyperbola, there's a lot of things that you can have that are different by 3. So that's why you have a graph that's unconstrained. It just goes on and on forever. But ellipse, there's not too many things you can add together, square and add together to get 1. So that's more constrained. That's why you have a finite figure there. In any case, Another one that's pretty tailor-made for us, right? Okay. So let's add these two together. I'll get 2x squared equals 4. So x squared equals 2. Uh-oh. What's x going to equal? Yeah, plus or minus the square root of 2. It's okay if it, if it doesn't work out as a nice even number. It's all right. We can work with square roots. So thanks, Bailey. Let's set x equal to the square root of 2. We'll deal with the positive one first. Square root of 2 squared plus 9y squared equals 1. Mindy, what's going to happen next? Can that simplify at all? Can I simplify that? Square root of 2 squared would be 2. Okay. Keep going. What next? All right, subtract 2. Y squared equals negative 1. Rachel, now what? Divide by 9 on each side. Good. And I think we can no longer ignore the 900-pound gorilla in the room. What's going on here? What kind of solution am I going to get? Don't say narn. Yeah, you're going to get imaginary solutions. Why are you getting imaginary solutions? Can anyone suggest a reason? All right. What's that mean in terms of the graph, though? Why are you getting imaginary solutions? Can anyone explain it from the graph? Why are we getting imaginary solutions? Yeah, these graphs touch each other only in your imagination, right? They don't really touch each other. So that's why you're not getting any solution, is because there is no solution. And you can see it from the graph. The unfortunate part for you is that it's tough to come up with these graphs on your graphing calculator. It's not something I'm going to cover. I don't even cover for my college algebra class. Not really. So there's no solution. And you see that right here when you have a squared term equals something negative. You can't square a real number to get a negative number. It has to be an imaginary number. We're not going to work with imaginary solutions, so that's it. There's no solution.
Would we know that as soon as we get a squared number, or as soon as we get...
Well, you got a squared term equal a negative number. That's when you can say, uh-oh, there's a problem. So, I always kind of like in the movie Apollo 13, they're 200,000 miles from home. Part of their spaceship blows up, and they radio back and say, Houston, we have a problem. It's just so deadpan and calm. Just nerves of steel to be out there and handle that. Okay. Let's try one or two more. Problem 44. So y minus x equals 0, and 4x squared plus y squared equals 10. Does this look like an addition method problem? No. So what should we do? Substitution. All right. What do you want to substitute? I don't have anything solved for to substitute. I mean, I could though. Is there something I can get by itself pretty easily? Sure. Let's move that x to the other side. and get y equals x, and that's special. If y equals x, let's plug that in right there. Can you simplify the left-hand side? Anyone simplify the left-hand side for me? Sure. 5x squared equals 10. So that means x squared equals, yes, x squared is 2. X is plus or minus the square root of 2. Well, that's special. If x is plus or minus the square root of 2, then guess what? That's what y is as well. Y equals plus or minus the square root of 2. In other words, your final solution should be square root of 2, square root of 2, and negative square root of 2, and negative square root of 2. Basically, like this. Square root of 2, square root of 2, and negative root 2, and negative root 2. So you got an ellipse and a straight line through the origin. So. Let's look at problem number 60. Now here's the graph for number 60. Now, I haven't solved this in several months, so I've kind of lost track of the solution. And I don't know exactly what the solution is. We'll find it in a minute. But take a look at the graph that I provided anyways. How many solutions do you think there are? At least. Anyone? I'm thinking there's 2. Maybe one here and one here. Kind of like that somehow. Not sure. But I'm thinking there's at least 2. Now what I don't know is, do these parts of the graph touch each other? That much I don't know. So maybe there's 2 more solutions that aren't graphed. But there's at least 2 here. And let's see that and work through the problem. So problem 60 is xy equals 1/12, which is a hyperbola that we're not going to deal with. At least we're not going to graph these things. It actually faces sideways, kind of diagonal. And then the other problem, or the other equation, is x plus y equals 7xy. Well, it's going to have to be substitution here. We can't add and get rid of one variable or another, so you're going to have to solve for one variable or the other. I think we have to solve for either x or for y from this equation. You're not going to get x or y by itself in the second equation because you get x and y on both sides. So, I mean, I suppose you could eventually, but it's a lot more work. Let's solve for x from the first equation in problem number 60. How am I going to get the... Say again? Divide by y on both sides. Or I could multiply both sides by 1 over y. Okay. And if I do that, if I multiply both sides of the equation by 1 over y, what happens? What's y times 1 over y? Y times 1 over y? Those cancel, right? So you multiply a number by a reciprocal. So here I get x is 1 over 12y. Okay. So let's substitute that into our other equation. I have to substitute it in here and here. Y plus 1 over 12y equals 7 times 1 over 12y times y. We get some simplification on this one. What's going to simplify here? Anyone? Yeah, the y's cancel each other out. Thanks, Krista. So I'm left with y plus 1 over 12y equals 7 over 12. It's still probably not, an attractive looking equation. You're not going to look at that and go, gee, I can't wait to solve that one. Why not? What about this problem might you not like? Fractions. 7 times x times y. So, yeah. No, I appreciate that. It's all right. I appreciate the question. I really do. What could I do here, though, to clean this up? And the least common denominator in this case is 12y. So 12y has to multiply everything, both sides. So 12y on the right, 12y on the left. Now when I do that, that 12y kind of distributes itself. So as Mindy said, multiply everything by 12y. y times y is 12y squared plus 1, equals 7y. Okay. All right, this is our last problem in this section. How are we going to finish solving it? What should I do next? Yeah, you want to get a 0 on one side. The easiest thing to do is minus 7y from both sides. Factoring it is a good thing if you can do it. Now, some of us can do it. Some of us might struggle. If you struggle, if you look at that and go, oh, I hated these things. I was just terrible at them. If that's you, what recourse do you have? How could you solve this one without cheating? Quadratic formula. Good. So hopefully you have that memorized. If you can factor it, all the better. But these are a little bit more challenging because you can't just look for two numbers that multiply to 1 and add to negative 7. Why can't I do that? Why isn't it that simple? Yeah, you got the 12 in front of the y squared. If it was just y squared minus 7y plus something, then you could look for two numbers that multiply to this and add to this. But if there's something that's in front of that, well, then it's not so easy. Is it worth it to practice a quadratic formula right now? Just one example? Yeah, probably not a bad idea. So let's see. A is 12, B is negative 7, C is 1. This is actually a great one to practice a quadratic formula. The easiest place to make a mistake is with a negative value for B. So let's write the formula here for the quadratic formula with a bunch of parentheses. And the reason I do that is because I don't want you to miss a sign. For instance, the negative of -7 or -7 squared. 12 times, or -4 times 12 times 1 over 2 times 1. And I can tell from the discriminant right here, and that's something we did earlier this semester. If this number is positive, you're going to get 2 real solutions. If it's 0, you're going to get 1 real solution. If it's negative, you're going to get 2 imaginary or complex solutions. But we're actually going to do a little bit better than that. 2 times 12. So 7, because the double negatives cancel, plus or minus the square root of 49 minus 48 over 24. 7 plus or minus 1 over 24. Now take a moment and write out both solutions. I'd not be happy if you left it like this, 7 plus or minus 1 over 24. You need to go a little bit farther. 7 plus 1 over 24 is 8 over 24, which is 1/3. 7 minus 1 over 24 is 6 over 24, which is 1/4. Yay. Any last minute thoughts on problem 60 there? So I guess we do need to do a little bit more work. Once you have x, or actually in this case we got y, we need to figure out what x is. So let's go back and figure that out. So this is really y equals 1/3 or 1/4. X would be 1 over 12y. So in this case, it's 1 over 12 times 1/3. 1 over 12 times 1/3 is 1 over 4. Or conversely, 1 over 12 times 1/4 is 1/3. So your points look like this. 1/4 and 1/3, and 1/3 and 1/4. That makes sense when you think about the graph we had. The graph showed that those two solutions were pretty close to each other. And we're seeing that now. If you look at those 2 points, yeah, okay, those are pretty close to each other. And that's what we saw here. You actually have to zoom in quite a lot to actually see a nice difference between those 2 curves before you can really spot those 2 points. But I think we're in good shape there. For homework, try 23 through 37. In a regular semester, I'd probably also assign 51, 53, and 59 maybe, but let's just keep it nice and friendly, 23 through 37.